Flower classification using supervised learning. Abstract biodiversity of Earth is very rich. About 360,000 create a healthy biome within the environment of Earth. Some of them are identical in physical appearance like shape, size, and color. Hence it is difficult to recognize any species. Similarly, iris flower species has 3 subspecies: Setosa, Versicolor, and Virginica. We are using iris dataset because it is frequently available. The dataset of iris flower contains 3 classes of 50 instances each. With the help of machine learning, iris dataset identifies the subclasses of iris flower. The paper focuses on how machine learning algorithms can automatically recognize the class of flower with the help of high degree of accuracy rather than approximately. There are 3 phases to implement this approach: are segmentation, feature extraction, and classification. Using neural network, logistic regression, support vector machine, and k-nearest neighbors. Keywords: iris dataset, k-nearest neighbors, logistic regression, neural network, scikit-learn, support vector machine. Introduction. Machine learning is program that learns from past data set to perform better with experience. It is tools and technology that we can utilize to answer questions with our data. Machine learning works on 2 values. These are discrete and continuous. The use and applications of machine learning has wide area like weather forecast, spam detection, biometric attendance, computer vision, pattern recognition, sentiment analysis, detection of diseases in human body, and many more. The learning methods of machine learning are of 3 types. These are supervised, unsupervised, and reinforcement learning. Supervised learning contains instances of a training data set which is composed of different input attributes and an expected output. Classification, which is the subpart of supervised learning where the computer program learns from the input given to it and uses this learning to classify new observation. There are various types of classification techniques. These are decision trees, Bayes classifier, nearest neighbor, support vector machine, neural networks, and many more. Some example of classification tasks are classifying the credit card transactions as legitimate or fraudulent, classifying secondary structures of protein as alpha helix, beta sheet, or random coil, and categorize the news stories as finance, weather, entertainment, and sports. Python is a programming language created by Guido van Rossum in 1989. Python is interpreted, object-oriented, dynamic data type of high-level programming language. The programming language style is simple, easy to implement, and elegant in nature. Python language consists of powerful libraries. Moreover, Python can easily combine with other programming languages, such as C or C++ or Java. Scikit-learn use the SciPy library of Python as a toolkit. Scikit-learn was originally called as scikits.learn. It includes dataset loading, manipulation, and pre-processing of pipelines and metrics. Scikit-learn has a huge collection of machine learning algorithms. To review criteria: the IRIS dataset is present at University of California Irvine Machine Learning Repository. The dataset was firstly acquainted by Edgar Anderson in 1935, but due to use of many classification methodologies, it was further generalized by Ronald Fisher in 1936 and also known as Fisher's IRIS dataset. Hence the characteristics of data are multivariate and based on real values. 1. David W. Korn and Giauddin Ersani proposed in their paper an evolutionary algorithm for nonlinear discriminate classifier, in which they mentioned that it was not appropriate for learning tasks with any individual single value. Hence they tested this method on 2 datasets, iris flower and balance scale, where decisions of class membership can only be affected collectively by individual lineaments of flower. 2. Ditlevnock and Rudolf Kruse have proposed a new approach in which they classify the data on the basis of fuzzy neural networks. They used backpropagation algorithm to define other class of fuzzy perceptron. They concluded that on increasing the number on hidden layer, increase the need of more training cycles and raises incorrect results. Hence the better result can be evaluated using 3 hidden layers also. 3. To overcome the problem of data depth, long parameters, long training time and slow convergence of neural networks. Two other algorithms, transfer learning and atom deep learning optimization algorithms, were considered for flower recognition by Jingfeng, Zhivan Wang, Minjia, and Ziliang Cao, where transfer learning was based on features in isomorphic spaces. They concluded in their paper that if the pictures of flowers placed into model training in the form of batches, then it will meliorate the speed of updating the value of parameters and provide the best optimal result of parameter values. For Rongguo Huang, Sanghaiyan Jin, Yonghyun Kim, Kwangsog Hong focus on recognition of flower using difference image entropy, DI, which is based on feature extraction. According to their research, the experimental results give 95% of recognition rate as an average. The dye-based approach takes original image of flower as an input, and applies pre-processing and dye computation to produce recognition result. 3. Proposed algorithm segmentation is the process which is used to remove the inadmissible background and consider only the spotlight, foreground, object that is flower. The main objective is to simplify the representation of the flower and to provide something which is more significant and easier to analyze. In feature extraction, we extract characteristics or information from flower in the form of real values like float, integer, or binary. The primary features to quantify the plants or flowers are color, shape, texture. We do not prefer only one feature vector because the subspecies have many attributes which are common with each other and produce less effective result. Therefore we have to measure the image by merging different feature descriptors which identify the image more efficaciously. The first 5 iris datasets are represented in the given Table 1. Table 1. The 5 iris datasets 5. After extracting features and labels from iris dataset, we need to train the system. With the help of scikit-learn we create machine models, which classify the iris flower into their subspecies. The following Table 2 represents the descriptive statistics of iris dataset. Table 2. The description of iris dataset. Neural network, iris species have less feature, therefore multilayer perceptron is used as the currently architecture of neural network to preclude overfitting. In multilayer perceptron model, there is one scaling layer, 2 perceptron layer and 1 probabilistic layer. Iris dataset has 4 attributes, hence input layer consists of 4 variables. These are sepal_length, sepal_width, petal_length and petal_width. The below graphs represent the relationship between sepal length versus sepal width, Fig 1, petal length versus petal width, Fig 2, sepal length versus petal length, Fig 3, and sepal width versus petal width, Fig 4. Fig 4. Relationship graph of sepal and petal width. The scaling layer is used for normalizing the input values. We use mean and standard deviation scaling method to calculate normal distribution of sepal and petal lengths and widths. The first perceptron layer consists 4 inputs and 3 neurons, and the other perceptron layer consists 3 inputs and 3 neurons. Both 2 perceptron layer uses logistic activation function. The probabilistic layer permits the outputs to be represented as probabilities and normalizes the feature of each dataset to the range of 0 to 1. The neural network produces 3 outputs as iris subspecies Setosa, Versicolor, and Virginica. Fig 5. Neural network in the first perceptron layer 10. Logistic regression falls under the category of classification algorithms of machine learning. It provides a baseline for any binary classification problem and is also used for multinomial classification in which more than 2 classes are ascertained. Using link function, logistic model is transformed to predictor. Regularization 12 is used to identify error of overfitting and underfitting in the proposed model while training data. Fig 6. The univariate plots are represented in the form of histograms. Support vector machine, SVM. In SVM dimensionality reduction techniques like principal component analysis, PCA, and scholars are used to classify dataset expeditiously. The first step towards implementation of SVM is data exploration. The initial configuration of hyperparameters like degree of polynomial or type of kernel are done by data exploration. Here we use two variables x and y, where x and y represent the features matrix and the target vector respectively. Dimensionality reduction is used to reduce the number of features in dataset, which further reduces the computations. Iris dataset have 4 dimensions. With the help of dimensionality reduction it will be projected into a 3-dimension space where the number of features is 3. We split the transformed data into 2 parts, these are 80% of training set and 20% of test set. Fig 7. The number of features in the new subspace is 3. K-nearest neighbors, KNN. KNN is used for both classification and regression. In KNN, we have labeled dataset which consists of training observations, x, y, and would like to establish the relationship between x and y. When KNN has unseen observation, then similarity is determined by distance metric between 2 data points. The distance can be measured by following method 16. Where n is number of dimensions, x is data point from dataset and y is new data point to be predicted. KNN does not take string labels. Hence label encoder is used to modify the string labels into numbers where iris Setosa, iris Versicolor, and iris Virginica are represented by 0, 1 and 2 respectively. Iris dataset are multivariate, therefore data visualization is done by several plotting methods like parallel. Fig 10. Pair plot is used to visualize the distribution of the relationship between multiple variables separately. Coordinates, Andrew curves, pair plot, box plot. Implementing KNN with scikit-learn, following 3 steps are performed: making decisions, evaluating predictions, and using cross-validation for parameter pruning. Using sklearn model the accuracy is 3. The dataset consists of 4 dimensions, where PCA compress the data and provides the number of features in the new subspace. Using linear SVM, the accuracy of training set is 0.97 and test set is 1.00, while using nonlinear SVM, the accuracy of training set is 99.17% and test is 100. And on tuning the C parameter, the best estimator accuracy on training set is 96 and on test set it is 100. 3.1 Using linear SVC. 3.2 Using grid search. 3.3 Using nonlinear SVC. 4. Using KNN classification, the accuracy of our model is evaluated to 96.67% and on finding the best K, the optimal numbers of neighbors is 9. Fig 12. Fig 12. The above diagram represents the optimal number of neighbors, which is 9. Table 3. The accuracy of classification model. Table 4. The accuracy of model using SVM.